In this video, we're going to talk about condensation polymers, specifically polyamides. We're going to tell you how to make these polyamides from generally carboxylic acids, acyl chlorides, and amines. Okay, and we're also going to go through some examples with amino acids, which are very, very common. So first of all, a polyamide itself. Okay, hopefully you should be familiar with amides, but a polyamide is made from an amine and a carboxylic acid, specifically in some cases a diamine and a dicarboxylic acid, or a diamine and a diacyl chloride. So the first example that we're going to talk about is when we use the acyl chloride, because that is the way you normally make a polyamide. And that's because you need to raise the temperature up to make a carboxylic acid react with an amine, okay, or you need to do it in a biological process. Okay, that's why most of the time the carboxylic acid that reacts with the amine will be in an amino acid, okay, because it's a biological molecule. Okay, but we're going to concentrate for the first example on the acyl chloride. So let's put that to the side and highlight our acyl chloride and our amine. Now, a lot of these times you do this example, they'll use derivatives of nylon. And nylon is basically a diacyl chloride, or in fact a dicarboxylic acid, because remember you can just heat it up to make it work, okay, and a diamine. So we're going to do a related example of that just has a carbon chain and a diacyl chloride and a diamine. So we're just going to put 3 to keep it simple, okay, and there is the start of my diacyl chloride, and then we put on our Cls. And if you've watched a few of these videos, you'll notice I put in red the elements that's going to make the small molecule that leaves, which makes this a condensation reaction. We then go from there to make our amine, and hopefully you should have some knowledge of amines. And again, we're going to make this a simple amine just with 2 carbons. So there is 1 amine. Okay, I'm going to draw the hydrogens on just to make it simple, and notice on this one, again, I'm going to draw that in red because that hydrogen will combine with one of these chlorines. Okay, and let's try and do it on the other side as well, because it's a diamine, and again, and then let's put that in red again. So we've got a diacyl chloride, we've got a diamine, and we know that what's going to happen, this red hydrogen is going to react with this red chlorine, and the end here is going to bond with this carbon. And if it's an amide, and that means we're going to have a bond formed here, and then we're also going to have our repeating unit formed when the hydrochloric acid from both ends, okay, which is made from both ends, disappears, and you make our polymer. But let's have a look at that and look at how we do it. And I'm talking to you as if you've done the polyester video, and hopefully you've done the polyester video and understand them. So there we go, we draw it out again. Okay, remember we're doing condensation reactions. This HCl leaves, this N bonds to this carbon here. There's the N, I'm redrawing the H that comes off it. I'm up to this carbon here. Okay, and I go back down to my other N, that's my N there. I've drawn the H, which is this H up here. This H and this chlorine are reacting together. Okay, and we're drawing a repeating unit of this polyamide. So basically, there you go. And remember, this chlorine has left, so there's your repeating unit. Now again, because we have 2 monomers, we've gone over this again in another video, because we have 2 monomers, for every molecule that we have here, for every repeating unit we have here, we will have 2n minus 1, okay, of our HCl. Okay, now again, that's because at the end of this polymer chain, it's unreacted. So we'll have 1 less water, 1 less hydrochloric acid than we would expect, because we would expect 2 hydrochloric acids per repeating unit. But remember, at the end, this bit here and this bit here, there'll be unreacted parts. And because there's unreacted parts, we'll have one less HCl than we would expect. And hence we have 2N minus 1 HCl. And that is how you draw a polyamide. Okay, and remember your amide group is this part right here. Okay, and again, you can have another amide here and here, but that's what makes your polyamide. And this is the first example which is related to nylon, because at the end of the day, if it's nylon, all that happens is this carbon chain here gets longer and this carbon chain here gets longer. Okay, and again, like I said before, you don't have to remember the examples. The different monomers will be given to you in the question. Our next example is going to be how to make a polyamide from an amino acid. Condensation, polymerisation, again, this time to produce water. Let's go through it. So the condensation to form that polyamide from amino acids is because you have an amine here and a carboxylic acid here. If you had an acyl chloride and an amine, you would produce hydrochloric acid, and that would make it a condensation reaction, a small molecule being removed. And if you have an amine and a carboxylic acid, you remove water, which again, small molecule, therefore condensation reaction. But let's move it across and talk about this as an example and show you a repeating unit of this. So first of all, we're going to do glycine. That means our R group, which is down here, okay, is just going to be a H. So there is our H, and then we have our carboxylic acid here. Now, when it comes to this, the carboxylic acid, it is the OH in the carboxylic acid that leaves, so I'm going to draw it in red. Okay, and then let's draw the rest. There's your H, and then one of the H's also leaves with it. Okay, so basically what's happening is another molecule of this has come to the side. The carboxylic acid is reacting with that H. Because the carboxylic acid is reacting with that H, you're losing water. So if we remove our water and draw it out again, okay, and then there is our carbon in the center, or our alpha amino acid. And we've just redrawn it all, but we've redrawn it without the water. So let's add the water on the other side. Okay, so there's our water. And now we just do our repeating it. Remember, this is going to be this bonded to another one of itself, okay? So that means we can just, because this is not skeletal formula, we can just draw that as a line, and we can just draw that as a line. And there is our repeating unit. Often when you go into exams, the brackets, they don't really mark, and the N, they don't really mark either, but we tend to put it on just because it tells you how much waters that you will make. And remember, there's one molecule here, so that means we will have N minus 1 waters for the entire thing. Now, that is just your repeating unit for this, and that would only change if the R group would change as well. Okay, so just get used to the fact that you can make a polymer from an amino acid, okay, and turn it into that polyamide, okay, which is, again, very similar to if you had, for example, a carboxylic acid or an acyl chloride and you had an amine in the molecule. It's exactly the same thing. So it's a single monomer used to make a polymer. And that is your two examples of how to make polyamides. In this video, we've gone over a couple of examples of polyamides as condensation polymers. We have gone through doing it with a acyl chloride and a amine, and done with a amino acid which has a carboxylic acid and an amine. There is another video that follows this which is on exam style questions, which I fully encourage you to now try.